Good morning students. Today we are going to study about the electromagnetic spectra based on energy and based on wavelength in the chapter structure of atom. In the previous classes we have discussed about what is a spectra, right, and what is electromagnetic spectra, what are the different wavelengths it have, right, how many groups of waves it have, and today we are going to discuss electromagnetic spectra based on energy and based on wavelength. So first of all, let us see based on energy. Electromagnetic spectra based on energy. Based on energy, here we have absorption spectra and emission spectra. Based on energy, we have absorption spectra and emission spectra. Now, absorption spectra. When electron gains energy, it jumps from the lower energy level to the higher energy level. Electron gains energy and jumps to lower energy level to the higher energy level. That is absorption spectra, right? So how this electron is going to receive energy, how it is going to gain energy. When it is heated or when it is irradiated, it is going to gain energy, it is going to absorb energy, and then it is going to jump from lower energy level to higher energy level. Right? Say for example, first energy level, second energy level, third energy level, fourth energy level, and the energy level goes on. If the electron is there in the first energy level, if it receives energy, then it gets a promotion, right? It does not want to stay in the first energy level. It wants to jump to the second energy level, which is highest energy level, right? Say for example, if the student that clears his exams, right? He don't want to sit in that section again. He don't want to sit in that class again. He wants to go to the higher class. So here also, when the electron gains energy, when it absorbs energy, it jumps from lower energy level to higher energy level. And while it is jumping from lower energy level to higher energy level, it is going to give you the dark lines with bright background. So in this absorption spectra, what is going to happen when an electron gains energy, jumps from lower energy level to higher energy level, right? While it is moving from lower to higher energy level, it is going to give you the dark line with the bright background. Dark line with the bright background. Let us see, it will be in this way. So dark line with the bright background. Dark line with the dark lines with the bright background. So these are the dark lines. These are the dark lines which is having a bright background. So this is going to observe during absorption spectra. Now coming to the emission spectra. Like absorption spectra, in the emission spectra also, the electrons jump from the higher energy level to lower energy level. When these electron loses energy, they jump from higher energy level to lower energy level. So these electrons are going to jump from higher energy level to lower energy level. So while they are jumping from higher energy level to lower energy level, they are going to give you this opposite one, that is the bright lines. Bright lines with the dark background, right? Dark background, right? In this way. So bright lines with the dark background. Bright lines. These are the bright lines with the dark background. So here, based on energy, we are going to study absorption spectra and emission spectra. Absorption spectra and emission spectra happens when an electron gains energy and loses energy. When electron gains or loses energy, they are going to change their energy level. If they gain energy, they jump to the higher energy level. If they lose energy, they jump to the lower energy level. while they are jumping from higher to lower or lower to higher, they are going to give some impressions, and that impressions are observed like dark lines and bright background in case of absorption spectra, and bright lines in dark background in case of emission spectra. Right? So the study of absorption spectra and emission spectra together is called as spectroscopy. Together it is called as what? Spectroscopy. The study of emission spectra and absorption spectra based on energy, that is called as what? Spectroscopy. So this is about the based on energy. Let us see based on wavelengths. Electromagnetic spectra based on energy, absorption spectra, emission spectra, jumping from higher energy, lower energy to higher energy level, leaving dark lines with a bright background. Emission spectra, they lose energy, jump from higher energy level to lower energy level, leaving bright lines with the dark background. Now let us see based on wavelengths. Electromagnetic spectra based on wavelength. Based on wavelength. And based on wavelength, we have two types, that is continuous spectra and discontinuous spectra. Continuous spectra and discontinuous spectra. In continuous spectra, let us see about the continuous spectra. Continuous spectra means a group of wavelengths with a different a group of waves with the different wavelengths are merged together. We do not see any difference between these colors. Difference between the colors. Let us see the example, that is VIBGR. Right? Already we have studied about the visible spectrum. So what is this visible spectrum? VIBGR. Ranging from 400 nanometers to 750 nanometers. And in that range, in that visible spectra, we have violet, indigo, blue, green, yellow, orange and red. So they have different waves with a different wavelength. When you observe a rainbow, right, do you see any difference or any gap between the colors? No, we do not see any such colors, any gaps between those colors. Take the example of the tricolor flag or national flag. Do you see any gap between the colors? No, we do not see. Right? One color is merged with the another color. There is a continuity with the colors. So that is why it is called as continuous spectra. All the waves with a different wavelength are merged together. There is no gap in between. There is no gap in between. Right? That is called as continuous spectra. Example: rainbow, VIBGR. Right? There is no gap. All the colors are merged together. There is no gap in between. That is an example for the continuous spectra. Now coming to the discontinuous spectra. In discontinuous spectra, we have again two types. One is line spectra and band spectra. Line spectra and band spectra. Now coming to this line spectra. What is this explains about? So line spectra is also called as atomic spectra. Atomic spectra, which is used to identify unknown atoms. Line spectra is also called as atomic spectra, used to identify the unknown atoms, because these atoms in this gaseous phase, right, they are not going to emit in different, they are not going to emit with the different waves, like from VIBGR, like from violet to red. They are going to emit only one light at particular wavelength, irrespective of the wave. Say for example, visible light. When a visible light is passed through the prism, it is going to produce violet to red color. Violet, indigo, blue, green, orange, yellow and red. But when this atom is in the gaseous phase, when it is passed through the prism, it does not produce any number of colors. irrespective of the wavelength, it is going to produce only one light. Only one light. So each and every element possess a different or a unique structures, unique spectra. Say for example, when there is a sodium light, right? When there is a sodium in the street lights, when these sodium vapors get ignited, they are going to emit the yellow color. In the same way, we have the copper chloride. When they get ignited, right, they are going to emit green color. And strontium chloride, it is going to produce red color. So in this way, each and every element will have a different light spectra. So based on this, we are going to identify the elements. Each and every element have a unique property. No two elements will have the same line spectra. Like the two persons do not have the same fingerprint. Right? My fingerprints are different from the other person's fingerprints. In the same way, element line spectra is different from the other element line spectra. Right? In the gaseous phase, they are not going to emit the multiple colors. Irrespective of the wavelength, they are going to emit only a one color. Only one color. They emit the light only at the specific wavelength, leaving the bright lines and the dark background. So this is what we are going to study in the line spectra, right? So in the line spectra, we have, it is also called as atomic spectra, used to identify the unknown atoms, because atoms in the gaseous phase, they are not going to emit the multiple colors, they are going to emit only one color at particular wavelength. At particular wavelength, giving the bright lines and the dark background. Bright lines and the dark background. And now coming to the band spectra. Band spectra is also called as molecular spectra. It is also called as molecular spectra, used to identify or used to know the molecular formula, the molecular compound. Molecular formula, right? Molecular formula, which have the sharp peak and the broad base, right? Sharp peak and the broad base. This is called as molecular spectra. Right? In the line spectra, we say that it is an atomic spectra. Each and every atom has a unique property, unique characteristic of emitting light. No two atoms will have the same nature of emitting light. Each and every, we have different elements, different atoms, and different element possess a different property of emitting light. Right? Say for example, crackers. When you light a cracker, right, it is going to give you the multiple colors. And no, all the colors are same, right? Not all the colors are same. That is because of the elements present in it. Sodium is going to give you the yellow color, copper is going to give you the green color, right? Strontium chloride gives you the red color, crimson red color. So these variations in the color explains about the variety of the atoms, right? Different atoms present in that different elements. And band spectra explains about the molecular formula, molecular spectra, which is having the sharp peaks and the broad base. This is all about the electromagnetic spectrum based upon the energy and based upon the wavelength. Based upon energy and based upon wavelength. Based upon energy, what we have discussed? Based upon energy, emission spectra and absorption spectra. Right? Absorption spectra gains energy and jumps from lower energy level to higher energy level. And emission spectra loses energy, jumps from higher energy level to lower energy level. And coming to the based on electromagnetic spectrum based on wavelength, we have continuous and discontinuous. Continuous example is rainbow, which have a multiple color at different wavelength, but there is no gap in that color. All the colors are merged together. Whereas in discontinuous, we have line spectra and band spectra. Line spectra is used to identify the unknown atoms, where these atoms in gaseous state are not going to exhibit the multiple colors, right? They are going to exhibit only a color at a particular wavelength, at a specific wavelength. And coming to the discontinuous band spectra, molecular spectra used to know the molecular compound, molecular formula by giving you the sharp peaks and the broad base. And in the next class we are going to discuss about the Niels Bohr atomic model of hydrogen and its limitations. Thank you.